Question number 6. The compound that gives the following NMR spectrum has the formula C3H6Br2. Draw its structure. So the first thing we could do here is write down the HDI for this compound. So the HDI is equal to 0. So no double bonds in this compound, no rings to worry about. And if you think about this molecular formula, C3H6Br2, there's only about 4 isomers for this compound. So I think the next thing to do is to look at the step curves here, and we can see these numbers that are written down here. Those are the relative heights of the step curve. So the step curve here and the step curve here. So the ratio is 2 to 4. And since I have 6 protons in my molecule, that must mean that this signal here represents 2 protons, and then this signal here represents 4 protons. Also, I can see that this one's pretty clear that this one is a triplet. So those 4 protons must be coupled next to 2 protons. And this one here is a quintet. So those 2 protons must be coupled next to 4 protons. And since we only have 2 signals, that means we must have some kind of symmetry in the molecule, because there's no such thing as a CH4. That doesn't exist. So there must be 2 CH2s that are resulting in this signal here, the more de-shielded signal. Right away when I look at the molecular formula, again, if I think about C3H6Br2, you might think, okay, well, if I draw C3 like this and I put 2 bromine atoms like that, then I have symmetry down the middle. There, maybe that's a possibility. Well, this compound would only give you one singlet, right? Because you've got a methyl group here and a methyl group here. So it can't be that. So let's go back to the spectrums here. So if we have a quintet, and it's represented by, or the 2 protons are split into a quintet, that tells you that you must have a CH2, and it must be next to 4 protons. So the only other possibility is to have them connected like this, because again, there's no such thing as a CH4. So this triplet represents 2 CH2s. So the triplet, I'll highlight it in blue, the triplet is represented by these 2 protons and these 2 protons. So then the only possibility for the bromines is to put them on the end like this, because bromine usually only, or in organic chemistry, only ever has 1 bond. So that's where we would put our 2 bromine atoms. And it makes even more sense now, because our triplet, our 2 methylenes, our 4 total protons, they're going to be the most de-shielded because they are alpha to an electronegative element, the bromine atom. So there you have it. So our quintet, because this methylene is going to be split by 4, and 4 plus 1 equals 5, and the other 2 methylenes, they're both going to be split into triplets, because 2 plus 1 equals 3. So there we go. So if you want to write the bond line, the structure of the compound, to make it look a little prettier, you could write something, write that right there. There we go. Problem solved.